Okay, so the preliminary part of this question reads: alpha, beta, gamma, and delta are roots of x to the power of 4 plus px cubed plus qx squared plus rx plus s equals 0. And alpha, beta plus delta, gamma, alpha, gamma plus beta, delta, and alpha, delta plus beta, gamma are roots of y cubed plus ay squared plus pr minus 4sy plus 4qs minus p squared s minus r squared equals 0. What is A? So as you can see, I've underlined the word roots, and I've done this because I felt that it was an important word, because what it did for me is that it reminded me of the section in A-level further maths on roots of polynomials, and what the roots of polynomials topic allows you to do is link the roots of a polynomial to its coefficients. So for example, if we have a here, so a is the y squared term of a cubic equation. So we'll have minus a will be equal to the sum of the roots of the equation. So alpha beta plus beta delta plus alpha gamma plus beta delta plus alpha delta plus beta gamma. So at present, this doesn't look too useful because we just have a bunch of terms on the right hand side. But a closer inspection, and if you remember your A-level further maths syllabus, will reveal that the right hand expression is actually the equal to one of the coefficients in the quartic equation, and the coefficient that it is equal to is q. So our final value for a is just minus q. Okay, so the first part of the question asks us to find the value of alpha beta plus gamma delta, given that it is the largest root of the cubic. And the question also gives us the values of p, q, r, and s, which are on screen. So the cubic that they want us to plug p, q, and r, s into is this one up here, y cubed plus ay squared, etc. And so instead of going through all the mental math, etc., I'm just going to write down the value of the cubic equation, which is, if I scroll up a bit actually, which is y cubed minus 3y squared minus 40y plus 84 is equal to 0. And so now they want us to find out the largest root of this equation. So to do this question, we're going to have to try and factorize this expression, or this equation, because as we know for cubics there are no simple formulas to calculate the root, and step is non-calculator, so we can't use a calculator to calculate the roots. So the best thing to do is to use the factor theorem and try to find a roots of the equation. So first, let's start off small. So let's try y equals 1. So if we plug y equals 1 into this equation, we'll get 1 minus 3 minus 40 plus 84, which clearly does not equal 0. So y minus 1 is not a factor. If we now try y equals minus 1, we will get minus 1 minus 3 minus plus 40 plus 84, and clearly also that is not equal to 0 because 84 plus 40 will be much bigger than minus 1 minus 3. So minus 1 is also not a root. Now let's try y equals 2. And by the way, the values of y that I am using are all factors of 84. Those are the only values of y that you should be testing, because only those can be roots of the polynomial. And so if we try y equals 2, we end up with 8 minus 2 squared minus 2 minus 12 minus 80 plus 84. And that, in fact, is equal to 0. So we now know that y minus 2 is a factor. So we can now start to factorize this expression. So if we write y minus 2 here, close the brackets. So because we have a y cubed term here, the first term in the second bracket must be a y squared with a 1 as a coefficient. We can also work out the last value in the bracket, because minus 2 times that last value must be equal to 84. And so we must have minus 42 here. So now we have to work out this middle term, which has a y. So if we choose any coefficient in the cubic, so for example minus 3y squared, so the y squared terms will be made up of these two terms here, so that'll be minus 2y squared, and then to get minus 3y squared we'll need to add another minus 1y squared, and the way that we're going to get that is by multiplying y by not plus y but minus y. And so this is what the above cubic factorizes into. And if you test the terms, we have multiplied these two, we'll get a y cubed. These two terms, so minus y squared minus 2y squared gives us minus 3y squared. If we test the minus 40y, if we multiply y and minus 42, we'll get minus 42y. We're then adding minus 2 times minus y, which is 2y. So we'll get minus 40y. And then minus 2 times minus 42 is 84. So we have now factorized this expression. And upon looking at the second bracket, we can immediately see that this can be factorized again to give us y minus 2 multiplied by y minus 7 multiplied by y minus 6. So as we can see, the largest root of the cubic equation is y equals 7. And so as you can see, 7 is the largest root of the cubic equation. And so alpha beta plus gamma delta must equal 7. Okay, so the second part of the question reads, hence, using the values of q and s, find the value of alpha plus beta times gamma plus delta, and then the value of alpha beta, given that alpha beta is greater than gamma delta. So before we move on, I just quickly need to correct a mistake I made that I just noticed. This should be a plus. Okay, so now when I did this question, the first thing I did was expand the brackets because it looked like it might yield some of the roots of the equation that we used in the preliminary part of the question. So when I did that, I got alpha gamma plus alpha delta plus beta gamma plus beta delta. And if we look back up to the roots of the cubic equation, all the back up here, they are alpha beta plus gamma delta, alpha gamma plus beta delta, and alpha delta plus beta gamma. Actually, I might just quickly copy them over so we can have a look at them. Okay, so I've copied and pasted the roots from the last part. I'm just going to draw a box around them to separate them out. And what we'll notice is that this term and this term over here make up the second root, and then these two terms make up the third root. And because we already know what the value of alpha beta plus gamma delta is, the value of this sum here is clearly just the sum of the remaining two roots. And if I scroll back up to the roots, we can see that the other two roots are minus 6 and 2. And so this expression is equal to minus 6 plus 2, which is minus 4. Okay, so now we need to find out the value of alpha beta. So we already know a relationship that relates alpha beta and gamma delta, and that is that the sum of those two terms is equal to 7. So what we could do as a method of attack is try to find another equation that links both of these two terms. And what sprung to my mind was the if we go back to the roots of polynomials, if we take the coefficient that has no x or y term in it, well, that term is just equal to the product of all the roots. And if I scroll back up to this equation here, the one with the x's, where the roots are alpha, beta, gamma, and delta, the value of s will just be the product of the roots. So we have that s, which is equal to, if I scroll back up again, is equal to 10, is equal to alpha, beta, gamma, delta. And from before we have alpha, beta plus gamma, delta is equal to 7. And so now these are just two pairs of simultaneous equations, and they can be solved via substitution. So because we want the value of alpha, beta, we'll have to substitute out the value of gamma, delta. So gamma delta will be equal to 10 over alpha beta, and substituting this in to the second equation will give us alpha beta plus 10 over alpha beta is equal to 7, and then multiplying both sides by alpha beta and rearranging will give us alpha beta squared minus 7 alpha beta plus 10 is equal to 0. And this can be factorized to give alpha beta, because we can just treat the alpha beta as a single term. Well, we'll get alpha beta minus 5 times alpha beta minus 2 is equal to 0. And so alpha beta equals 5, or alpha beta is equal to 2. So which one is it? Well, if we think about the two equations, so if I label this 1 and 2, the two equations are symmetric in alpha beta and gamma delta. And so what I'm saying is that if we instead decided to substitute in alpha beta instead of gamma delta, you would end up with the exact same equation as we just did here, but instead of alpha beta, we'd have gamma delta. And so one of these roots is the value of alpha beta, and then the other root is the value of gamma delta. However, we need to decide which one it is. And if we scroll back up to the question, we can see that we are told alpha beta is greater than gamma delta. And so alpha beta is a value of the greater root, and so alpha beta is equal to 5. The last part of the question reads, using these results and the values of p and r, solve the quartic equation x to the power of 4 plus px cubed plus qx squared plus rx plus s equals 0. And I've written the values of p, q, r and s, and I've also written down what we learned from the last part, so we know 3 pieces of information. So this question is essentially asking us to calculate the values of alpha, beta, gamma and delta, as these are the roots of the quartic equation. So a good strategy would be, because we have equations with alpha and beta together, would be to get another equation involving alpha and beta, and then using simultaneous equations to find alpha and beta, and then doing the same with gamma and delta. So as the question suggests, maybe we should use the value of p and r. And if we look at the equation here, we have px cubed. Now, the value of the coefficient of p using roots of polynomials will be equal to the sum of all the roots. And since p is 0, we have alpha plus beta plus gamma plus delta is equal to 0. And in fact, I can put brackets around these. And as you can see, if I label this equation 1 and this equation 2, we can make a substitution in order to solve for either alpha plus beta or gamma plus delta. So just without loss of generality, I'm just going to solve for alpha plus beta. And so if we do that, we will end up with, so if I substitute gamma plus delta into this equation here, I will get alpha plus beta times minus alpha plus beta is equal to minus 4. So alpha plus beta squared is equal to 4. And so alpha plus beta is equal to plus or minus 2. So 1 of alpha plus beta equals 2. And since equations 1 and 2 are symmetric, that means one of the roots will correspond to the value of alpha plus beta, and the other one will correspond to the value of gamma plus delta. If we now do what the question says again and consider the value of r, well, r is the x term, and so we will have minus r, which is equal to 6, is going to be equal to alpha beta gamma plus alpha beta delta plus beta gamma delta plus alpha gamma delta. And this expression can be factorized to give alpha beta gamma plus delta plus delta gamma alpha plus beta, and this is equal to 6. And so we have 5 gamma plus delta plus 2 alpha plus beta is equal to 6. And since alpha plus beta plus gamma plus delta is equal to 0, we can make another substitution to get that 5 times minus alpha plus beta plus 2 alpha plus beta is equal to 6, which means that minus 5 alpha plus beta plus 2 alpha plus beta will be minus 3 times alpha plus beta. So minus 3 alpha plus beta is equal to 6, and so alpha plus beta is equal to minus 2, and hence gamma plus delta is equal to 2. Okay, so now we know that alpha plus beta is equal to minus 2, and that alpha beta is equal to 5. And we know that gamma plus delta is equal to 2, and that gamma delta is equal to 2. So now we can solve simultaneously for alpha, beta, gamma, and delta. So if we do the alphas and betas first, if we substitute out alpha, we will get beta times minus 2 minus beta is equal to 5. And so beta times minus 2 minus beta is equal to 5. And so minus 2 beta minus beta squared is equal to 5. And so beta squared plus 2 beta plus 5 is equal to 0. And so if we complete the square, we will get beta plus 1 squared plus 4 is equal to 0. And so beta is equal to minus 1 plus or minus 2i. And actually, because the two equations were symmetric in alpha and beta, we get alpha and beta is equal to minus 1 plus or minus 2i. Doesn't matter which way around they are. And then if we do the same for the gammas and deltas, we will get that, if I just, without loss of generality, if I substitute one of them out, we'll get gamma times 2 minus gamma is equal to 2. And so minus gamma squared plus 2 gamma is equal to 2. And so gamma squared minus 2 gamma plus 2 is equal to 0. And so if I scroll down, and so completing the square again, we'll get gamma minus 1 squared plus 1 is equal to 0. And so delta and gamma will be equal to 1 plus or minus I, and it doesn't matter which way they are. And so now we found all the roots. So the roots are 1 plus or minus I, and if I scroll up, minus 1 plus or minus 2i.